what we talked about last week, right? So place each sequence in an input-output table and use words to describe the sequence. So if I've got 2, 4, 6, 8, 10, what's my common difference?
2.
2. All right, so my common difference is 2. And so if I'm using an input-output table, remember sequences always start with that first position. What term is in the first position? 2. What term is in the second position?
4.
And the third?
6.
And the fourth?
8.
Okay. So if you're making a description, so add in words to describe the sequence, include the starting value and the pattern of the sequence. So where did the sequence start? Good. Why don't you turn on silent? Thank you. Okay. No, Washington. I'm not worried about it because your phone should help you out. Okay. Starting at 2, and what's happening every time? What's our pattern?
What's 2?
We're adding 2 to each term. Okay, so the second one, 3, 6, 9. Okay, common difference is 3. What's my first term? Second term? Third?
12.
Okay. So, again, my start is, and what's happening every time? Okay, so essentially, this description that we just made here and here is what our recursive rule is going to tell us. Okay?
What is recursive?
Our recursive rule. Our recursive rule mathematically tells us where am I going to start and how am I getting to the next term. So our recursive rule actually doesn't help us get to, let's say, the 100th term, because you would have to sit there and add 2 and add 2 and add 2 100 times, right? But our recursive rule just explains where do you start, what's the pattern. All right, so all of this, there's nothing for us to fill in down here, but it's basically a description of a recursive rule. If my example, 4, 6, 8, 10, 12, I know my common difference is 2. So the recursive rule is this. It says A of 1. So remember A of 1, this is the name of the sequence. And this is the first term, right? That is the end value, that's the position. So A of 1, the name of the sequence is A, you're looking for the first term. So the first term is 4, that's where I start. So every term after that would be A of n minus 1 plus 2. Okay, I'm going to explain what it means. I have a sequence. A of 1, give me a term.
5.
5, great. Okay, A of n minus 1, give me a common difference.
4. 6.
4, I heard 4 first. Okay, so this is my first term. And this is my common difference. Okay, so those are things that we already know. This is what we talked about in the warm-up. What does this mean?
Starting.
Now, if this is your position, what is n minus 1? The previous. So this is the previous term. Not before the starting. So I'm gonna go through and build the sequence using this rule, and hopefully it'll make a little bit more sense. So my first term is 5, right? Okay, so if I'm trying to find my second term, that means that n is 2. Everybody agree with that? So I'm going to replace my n with 2. Well, what's 2 minus 1? 1. Do I know what a of 1 is? What is a of 1? 5. And 5 plus 4 is 9. So my second term is 9. When I go to find my third term, I've got 3 minus 1. What's 3 minus 1? 2. Do I know what a of 2 is? Yes, it's 9. You just found it. So that means that I'm going to replace this with 9. And 9 plus 4 is 13. Okay? So basically it's saying the recursive rule says, what's your first term? And use the previous term, add the common difference to get the next term. And that's how you would build it. Okay? So that's all it's saying. It's just saying this, but in math notation. Okay? So hopefully that took something that looked really weird and made sense of it. So that's your recursive rule. Flip over and we're going to give the sequence given the rule. So a of 1 equals 7. A of n equals a of n minus 1 plus 4. So let's get the important information out of there. What's my first term? 7. Okay, what else is important? Plus 4, and what does that represent? The common difference. So I'm going to be able to add 4 all the way across my sequence. So then what is the second term? 11. What's my third term? What's my next term? What's my next term? 23. Okay. Does that make sense? All right, so let's look at number 2. What's important? First term. What is my first term? 12. What else is important? What is the common difference? Good. So I can minus 3 all the way across my sequence. So then what's my second term? 9. My third term? Next. Next.
0.
Very good. Okay. Y'all do 3. Okay. What are the first 5 terms of my sequence?
-5, -3, -1, 1, 3.
First 5 terms. Okay. Now we were matching. What is this sequence matched to? D. Good. Next one.
C. C. E. A.
Okay. Good. So now we have gone through the recursive formula, and now we're going to talk about the explicit formula. We wrote the explicit formula on Friday, but what we wrote was the simplified explicit formula. So there is an expanded form, and we're going to take this recursive rule, this is a recursive rule, and translate it into an explicit rule using the formula. Okay? It's the bottom of the one that we were just on. So 2, 5, 8, 11
Plus 3.
plus 3. Okay, so I'm going to flip the page. I know my first term is 2. And I know that my common difference is 3. So the explicit formula says a of n equals a of 1 plus n minus 1 times d. Now, the parts of that we know are a of 1 and d, right? So you're plugging into a formula again. You're plugging things in and you're using the same values. So if I plug in 2 for the first term and 3 for the common difference, and then I distribute out this 3 and simplify, does this look familiar, this final spot? Yeah, that's what we did on Friday, right? Because if I look back at the table, you don't have to flip back. But if I'm adding 3, how do I get back to the 0 term? Minus 3. What's 2 minus 3? Negative 1. And so where do you think that this value came from? It's the y-intercept. Okay, yes.
Added like the second step, step 2. Added 3. And what does 3 on the other side?
You can write it either way, because with distributive property says that whether the value is attached to the front or at the back, you would distribute it.
Well, like it's 3 minus 3 and minus 3. The last minus 3, you have add 3 again with it. But then
Wait, no, I'm just combining my terms.
oh, no, I'm just saying. Wait, is that what you said? No. Okay.
No, because 2 minus 3 is 8.
Oh, okay.
So, I want to quickly discuss something now. This is different than that. Because we have n minus 1 in parentheses, but it's not a of n minus 1. If it does not have the name on it, we're not talking about the previous term. You're plugging in a value for n. So if I take that sequence and I did the same thing that I just did with the last one, was the first term was 2, right? And the common difference was 3. And I plug it in. I say, okay, well, the first term is 2, and my function is a of n equals 2 plus n minus 1 times 3. If I'm finding my second term, what am I replacing n with? 2. What's 2 minus 1?
4. 1. 3. 2 plus 3. 5.
So my second term is 5, but 2 plus 3, 5 plus 3. Okay, so I can just plug into the position to this one. All right, most of the time you are going to be writing the simplified way. Y'all did that no problem on Friday, but you need to be able to recognize the expanded form, because when you see multiple choice questions on a test, a lot of times they'll say a sequence is defined by 2 plus n minus 1 times 3. You need to know what to do with that. All right, so let's practice. Down at the bottom, 4, 8, 12, 16, 20. What important information can I get from that?
Plus.
Okay, the difference is 4. I agree. The difference is 4. What else is important? The first term. It's important for both the recursive and the explicit. So let's build recursive first. My first term, f of 1, is 4. So every term after is f of n minus 1 plus 4. It's just the previous term. It's the recursive rule. So when you're looking at the recursive rule, this part never changes. You always start your recursive rule with your first term, and then f of n equals f of n minus 1, or whatever the title of your function is. Let's build the recursive rule for the next one, and it'll start to make more sense. 5, 8, 11, 14, 17. What's my first difference? 3. What's my first term? 5. So I need my first term, which is 5. And then I'm going to start the exact same way and just throw the common difference on the back. So f of n equals f of n minus 1 plus 3. So again, this section doesn't look any different for any recursive rule. It's just filling in your stuff.
Oh, that makes sense.
Okay? Okay, flip the page for me. I want you guys to write the recursive formula for 3, just the recursive. Then we'll go back and we'll do more simplified. So just the recursive. So I went around and kind of spot checked, and everything looks good as long as you have your first term and everything else. Just add the common difference. So plus 4, this one was plus 3. This one was minus 3. And this one was plus 1. Okay. So y'all's recursive rules look really good. Let's go back and start filling in some explicit. Yes. Fn minus 1. Okay. Your attention needs to come back to me. Thank you. All right, so you need the same information for your explicit rule. So the first problem says explicit formula, but look at the second one. It says simplified explicit formula. When you see simplified, we're talking about slope, intercept, form. So what we did on Friday. All right? But when you just see explicit formula, start with the expanded. Okay? Just for this one. If I ask you for the explicit formula and on a test, some of you give me expanded and some of you give me simplified, it's fine. It's the same thing. So, explicit formula. You don't need to list your first term because your first term is in the formula itself. So, f of n equals our first term. What's our first term? 4 plus n minus 1 times our common difference, which is what? 4. Nope.
And then do distribute the 4.
If you're simplifying it, you do.
Okay.
If you're simplifying it, you do. Because if I went back and found my 0 term, it would be 0, right? Everybody agree with that? Yeah. So my simplified version would be 4n plus 0, or just 4n, right? What would happen if I did distribute that? Okay, so 4 plus 4n minus 4. When I simplify, 4 minus 4 is 0. So whether you go back and find your 0 term or your intercept and plug it in, or you simplify explicit, we're making it back to the same place. Okay?
So for explicit, you just have to solve for the y or the term.
Okay. Let's write it again, but this one wants simplified, so slope-intercept form. So what would my slope be in this scenario? 3, right? The 3n. And just like on Friday, this second piece can't be found until I do what? I have to go get the 0 term. So I add 2 at the end. 3n plus 2. Okay? You all right?
No.
Okay, let's do another one together. Which type of explicit is it asking us for? Simplified explicit. So it wants slope-intercept form, the easier one. Okay, so slope-intercept. What's my slope? 4. So f of n equals 4n. Number 3. Okay, so if I'm adding 4 every time, what's that 0? Negative 4, so 4n minus 4, guys.
I think I just put too much stuff on my paper.
Yes. Not simplified. So number 5 is asking for just the explicit formula. So we want the expanded version. Okay, so f of n equals, what's my first term? 6. I'm looking at number 5. Okay. So 6 plus n minus 1. Now, what do I need on very end there?
-3.
Negative 3, the common difference. So again, a part of this that will never change. This will never change, and this will never change. You're just adding in your first term and your common difference. Okay? All right. Your task is to write the explicit formula for 4 and 6. One of them is simplified, one of them is not.